Going to start at the graded potential. So we're going to talk about receiving stimuli. So if you want to pause the video and write down what I have on the screen, that'll take some time, and that way as I talk you already have this written. So go ahead and pause, write down what's on the screen. There's a little bit more that's going to pop up down here, and you get it as we talk. So please pause, write it down, and then we'll talk. All right, so the graded potential is we're really talking about information coming in the dendrites. Remember, information comes in the dendrites and goes to the soma, and eventually is going to go down this axon, which we'll talk about that on the action potential. So the graded potential is here at the dendrites and the soma. So dendrite soma. And the thing about graded potential, because we're going to talk about the difference between action potential and graded potential will depend on the size and the type of stimulation you've got coming in. So sometimes you've got some positive information coming in telling the neuron to act, and sometimes it'll tell the neuron to stop acting. So we're going to see a variation. It's graded. You know, sometimes you get A's and sometimes you get B's, and so sometimes it's good, sometimes it's bad, etc. So we're going to look at the different types of stimulus that comes in to the dendrites or sometimes comes directly to the cell body. So again, our graded potentials are here. So you have EPSPs, which are excitatory. So I put a underline excitatory postsynaptic potential. So you just remember the E is excite. So it's going to stimulate, it's going to tell that neuron to do something. And so the way it does that, it allows sodium to come into the neuron. So we'll be talking about this in face-to-face, but anytime sodium comes into the neuron, you're going to get what's called depolarization. Remember the salty banana? The 3 sodiums are going out and the 2 potassiums are going in, which leads to a polarized resting membrane. So if we go opposite salty banana, so the sodium is now coming in, it is going to excite and it's going to cause a depolarization. So anytime sodium comes in, depolarization. Sodium comes in, depolarization. What that means is we're going to see the voltage kind of change. It is a positive stimulus. And so the IPSP is inhibitory. Inhibitory means you're going to stop doing that. It's going to stop that firing. It's going to close some doors and things like that. And so what you need to know about that is that it's going to allow some negativity, which is some chloride ions. So it's going to allow some chlorine to come into the cell. And so that's just going to make it more negative. Remember, inside the cell at rest is negative. So it's just going to make it more negative if more negative stuff comes in. And then it's going to allow some more sodium out. So we send the positive people out, or the positive ion out and the negative ion in. We're just going to get more and more negative inside. So if you get more negative, you are not depolarizing, you're actually becoming hyperpolarized. Remember, polarized means negative on the inside. So inhibitory is a negative stimulus, so it's basically going to stop things from happening. So we're going to go up here to the dendrites. Remember, that's where those information's coming in, and I'm just going to put some stimulus, and rather than put the PSP part, the postsynaptic potential, I'm just going to put E. So we're going to have an excitatory stimulus coming in. I'm just going to call him E1, and he's going to be firing on this neuron. So we get a fire coming in from here. So that's an excitatory one. I'm just going to put an inhibitory one over here. So we'll call him I1. And then we're going to come down. I'm just going to put a few more stimulus on here. So we're going to, on this dendrite, we're going to have some, call it E2. We're going to excite. So this one's causing some excitement. This one over here is going to cause some excitement, and so these are just stimulations that are going into this, and so these E guys are allowing sodium to come in. There are channels on this that are opening, but we're not going to focus on that, not on the graded potential. And then let's just draw another one for here. So this is going to be E4, and we're going to let that one be exciting. So we got a bunch of them that are exciting, and we've got one that's inhibiting. Going. So these are some things that are making it more positive in here. Remember, the resting is at a negative 70 millivolts. That's at rest. That's an important number. That was at rest. That was from the resting membrane. So all this down, if we stuck in there, is a negative. So these are going to allow some positivity in there. So we're going to see that number get bigger. This is going to allow some negativity in there and some positivity out. So we're going to see this make it more negative. So that leads to our next couple of vocabulary words. And so I'm going to scoot down. If you want to pause the video here, it leads to what we call summation. So here in the soma, those stimulus will get summed. So pause the video, write these two words down, and then I'm going to come back and I'm going to be writing something right here. All right, so hopefully you pause the video. And so summation is just when the stimuli, which is just plural for stimulus, get added together because they're coming in from all different directions. You have two different flavors. You've got temporal, and then you've got spatial. So let's pick spatial first because that one's a little bit easier. This is when you get two or more stimuli coming in from different directions. So they're coming in from maybe different dendrites, and they get added together because so they're kind of spaced out there. So this would be like if I were to add this E2, E3, and E4 together. They're coming in from different directions. That's a spatial summation. And so if I add that E2, which was that, and then an E3, these are all excitatory. I could put that inhibitory, it would subtract. It's just like a math equation. It's like a calculator. E4. These would sum, you know, in math, when you add up things, they would all sum together, so they would equal a bigger stimulus. That's called spatial summation. Temporal, it's a little bit harder for us to understand, but what it would be if this one would be rapid firing. So it would be shooting. Let me erase a little bit before I made that one a little too long. So it would be like this one, sending a stimulus, sending a stimulus, sending a stimulus. Like it's all like pow, 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 pow. It's sending multiple signals, and they just kind of keep firing, and it's not allowing this axon to reset. So this would all add together in here, and so that's what temporal is. It's basically coming from one area, but they're being sent like one after another. So this would be like that E1, but it would be going pow, 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 pow. So you would see that E1 and all these would be putting together, and this is E1 firing the same thing, and that is a temporal. And so those are the types of summations. And so with a graded potential, if the summation is big enough to overcome our negativity in here, we might start to see an action potential. So graded potentials sometimes will happen and sometimes won't, because it depends on the stimulation that comes in. So that's pretty much an overview of graded potential. That's going to lead us to the action potential, which is going to take place right here. If enough of these excitatories come in and we make this thing become less negative, here at that axon hillock, which is going to be called the threshold, we're going to see an action potential take place. So we're going to pick that up, and we'll talk about action potential on the next video.